How are you all? I hope that you all are good. As we know, the series of motion in a straight line is going on, and we have successfully finished the 10 lectures, right? So, in a previous lecture that we have discussed about equations of motion in case of a vertically projected body from the height of the tower h. Okay, and we have discussed some balloon and stone problems. Okay, so at the end of the session that we have discussed about a ball when it is thrown from the tower of height h in three different cases. Okay, so one is thrown in a vertically upward direction from the height of the tower, and the second one is thrown vertically downward direction with certain initial velocity u, and the last ball is thrown with a initial velocity 0. That means it's just like a freely falling body. Okay, now so in these three cases, so what are the equations for initial velocity, what is the height of the tower, and what is the time taken by the object to reach the ground in a third case? So all these things that we have discussed in a previous lecture, right? So this is a 11th lecture of motion in a straight line, and this is the small concept. Okay, so in this session that we are going to discuss about equations of motion in case of a vertically projected body as well as freely falling body. Okay, but here we are considering the air resistance force. We are considering the air resistance force. So whatever the equations of motion that we have discussed in a previous lectures, so in all the lectures, so we have neglected the air resistance force, but in this lecture we are counting the air resistance force when the object is moving in an upward direction or freely falling towards the ground. Okay, so right, small concept, only concept is there, no example problems and etc etc, just listen the concept. Okay, so my name is Rakesh. Welcome to our beautiful physics channel, Rakesh sir Physics. Right, shall we start the session? Right, so what is the chapter going on? Motion in a straight line. And what is the class number? This is a class number 11. Okay, right. So what is the topic? Equations of motion in case of air resistance taken in count. Air resistance is taken in count. So what is the meaning of air resistance? Okay, have a look. I'm taking the first case, case number 1. In this, from the ground, I'm just projecting an object from the ground with a initial velocity u, As we know that this object is moving in a vertically upward direction. Okay, like this, it is moving like this. Okay, so what is its initial velocity? U is equals to u. What is the acceleration due to gravity? A is equals to minus g. At a maximum height, what is its final velocity? 0. Okay, so let us consider this height is h. Height is how much? S. So what is the displacement? S is equals to h. Displacement is equals to h. Okay, so have a look. Here we are considering the air resistance force or air resistance, whatever it is, we are considering air resistance force. So whenever you are projecting an object in a vertically upward direction, so what happened? This object is moving like this. Okay, so whenever the object is moving away from the ground, so the air resistance force is opposes this object, and it acts in opposite direction to the motion of an object. Are you getting? So whenever you are moving in a bike, with a 20 meter per second, so what happened? You are moving in this direction. This is the direction of the velocity. Have a look. You are moving on the bike in this direction. Okay, this is your direction of moving. Now what happened? You feel that the air resistance force will oppose you. The air resistance force will oppose you. So if you are moving on the bike with a more speed, so more air resistance force acts on you in a opposite direction to the direction of your velocity. Direction of your velocity is this, and the air resistance force is acts in a opposite direction to your direction of motion. So if you comes to here, this is the direction of motion of the object, and the air resistance force is opposite the motion of this object. Are you getting? So air resistance force is acts in a opposite to the direction of motion of this object. Okay, so as we know, whenever the object is moving in an upward direction, or any object is moving in an upward direction or moving towards the ground, as we know, the gravitational force, what is that? F is equals to mg, acts in downward direction. So what is mg? Mg is nothing but what? It's a gravitational force. So the gravitational force is acts in a downward direction. Also, the air resistance force is also acts in a downward direction, because the object is moving away from the ground. So to the direction of motion of the object, the air resistance force is acts in an opposite direction. That means this air resistance force is try to oppose the velocity of the object. Try to oppose the velocity of the object. Just like a bike example. Okay, you are moving in this direction and the air resistance force is opposes you. Okay, right. So the net force acting on the object, F net means what? Net force acting on the object is equal to, have a look, the gravitational force is acting in a downward direction plus air resistance force also acting on the object. Okay, right. So according to Newton's second law, F is equals to, we can write ma. F is equals to how much? Ma. Just to substitute, F net is equals to ma is equals to mg plus r. So just bring this m to this side, it becomes mg by m plus r by m. Okay, so m get cancelled out, then acceleration is equals to, we got how much? G plus r by m. A is equals to, we got g plus r by m. Next up, I'm just taking the first equation of motion. First equation of motion. So what is our first equation of motion? What is that? V is equals to u plus at. V is equals to u plus at. So what is the final velocity of the object at a maximum height? 0. And if u comes to this side, it becomes minus u is equals to, a is equals to how much? It is a upward projected body, and acceleration due to gravity is minus. So minus minus get cancelled out. So u is equals to, what is the value of a? A is equals to how much? G plus r by m into t. Are you getting? I'm just substituted this a value here. Okay, so a is equals to how much? G plus r by m into t. So from this condition, I'm just writing the equation for time. So what is that? T is equals to u by g plus r by m. So what is this? This is the time taken by the object to reach the maximum height from the ground when the air resistance force is taken in count. Is taken in count. So as we know that the time taken by the object to reach the maximum height from the ground is called what? Time of ascent. What is this? Time of ascent is equals to how much? U by g plus r by m. U by g plus r by m. Okay, right. Have a look. Okay, note. So what is note? Have a look. When there is no air resistance force, no air resistance force, then what is the equation for time of ascent when there is no air resistance force? We already solved in a previous lectures. So time of ascent is equals to how much? U by g. Okay, so in the presence of air resistance, in the presence of air resistance, okay, what is the time of ascent? Let us say time of ascent in case of air is equals to how much? U by g plus r by m. Okay, right. Just observe these two equations. Just observe these two equations. Have a look. Time of ascent when there is no air resistance force, how much? U by g. Time of ascent when there is a air resistance force is there, how much? U by g plus r by m. So which value is greater in these two? Absolutely, it is clear that time of ascent is greater than time of ascent in a air. Okay, this value is greater than this value. Are you getting? Have a look. Here denominator we have only g. For example, u is equals to 5 and g is equals to acceleration due to gravity 10. 5 1 are 5 2 are 1 by 2 means 0.5. Okay, so if you comes to here, what is the value of u we are taken? 5. So what is the value of g? 10 plus, let us consider r by m is equals to, just for example, r by m is value and taking of 5. So 5 by 10 plus 5, how much? 15. 5 1 are 5 3 are. Okay, you will get a 0.333. Are you getting? TA is equals to 0.5 is greater than TA air. How much? 0.333. Absolutely, this value is greater than this value because here the denominator we have G plus something. G plus something. Absolutely, it becomes more than this. Then, whenever the denominator value is greater, then what happened? Overall answer will be decreases. So here also the overall answer is decreased to 0.333. That means the time taken by the object to reach maximum height in the absence of air is greater than the time taken by the object to reach the maximum height in air resistance force is taken in count. Are you getting? This means the time taken by an object to reach maximum height is more is more free space as compared to as compared to when air resistance force is taken into count. Okay, when the air resistance force is taken into count. Are you getting? That means in the absence of air, the time taken by the object to reach the maximum height is more. That means it travels more distance. It travels more distance. But in the presence of air resistance force, the time taken by the object to reach the maximum height is less. Maximum height is less and it travels less distance because it is moving like this, but the air resistance force is opposite that object, so that's why it reaches to the maximum height quickly, but it covers the displacement is a small. Are you getting? Right. So let us see the second case. So this is what case 1 and case number 2, and this is what freely falling body. Freely falling body. Okay, so have a look. So this is what ground. From certain height h, an object is moving towards the ground. An object is moving towards the ground, and it has an initial velocity is 0, and acceleration due to gravity is plus g, and it has some final velocity. Now the object is moving towards the ground. In which direction the air resistance force is acts on that object? And absolutely the air resistance force is acts in the direction opposite to the direction of the motion of object. Have a look. This is the direction of motion of the object, and the air resistance force is acts in opposite to direction of its motion. So what is this? Air resistance force, capital R. As we know, on any object, the gravitational force is always acts in a downwards direction. Okay. Now, what is the net force acting on that body? F net is equals to mg, gravitational force. So, for this gravitational force, air resistance force is what? Opposite. That's why I'm taking minus. Have a look. These two are opposite to each other. This direction, this direction. So that's why I'm taking mg minus r. Okay. So what is F net? F net is nothing but mass into acceleration, that is equals to mg minus r. If you send m to that side, it becomes g minus r by m. So acceleration of the object is equals to how much? A is equals to g minus r by m. Okay. Right. So I'm taking the first equation of motion. What is that? V is equals to u plus at. What is the initial velocity of the object in case of a freely falling body? 0. And the final velocity V is equals to at. Right. So final velocity V is equals to, what is the value of A? G minus R by M into T. We know that the time taken by the object to reach the ground from certain height is called what? Time of descent. Then time of descent is equals to, we got V by G minus R by M. The time of descent in case of air resistance force is present. Okay, are you getting? Right. So in a general case, note, in a free space, in a free space, that means there is no air or something. Okay, in a free space, what is the time of descent? This is equals to u by g. Td is equals to how much? U by g. But here we got how much? Td in air. But Td in air is equals to how much? V by g minus r by m. So which is the greater value and which is the least value? Have a look. Here denominator we have only g. Here we have the denominator g minus r by m. G is subtracted from r by m. That means overall this value is less. The denominator value is less. If the denominator value is less, then this time of descent in case of air, time of descent in case of air is absolutely greater than time of descent in free space. In free space, are you getting? Right. So time of descent in the presence of air is greater than time of descent in case of free space. Have a look. In these two conditions, in a which case the object is hits the ground quickly. The object is hits the ground quickly. In these two conditions, in a which case the object hits the ground quickly. That means the time taken by the object to hit the ground is less. Which one? Absolutely Td in a free space. Okay, so when there is no free space, the object hits the ground quickly. But in the presence of the air, the time taken by the object to reach the ground is more. That means the object hits the ground slowly. Compare with this is hits the ground slowly because the time taken by the object to reach the ground is more than hits slowly. So in this case, the object is hits the ground quickly. Compare with this. Are you getting? Any doubts? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So we got the equations for time of ascent as well as time of descent in case of upward projected body and freely falling body in the presence of air. So what are those? So time of ascent is equals to how much? U by g plus r by m. And second one, time of descent in the presence of air. In the presence of air, we got how much? V by g minus r by m. V by g minus r by m. Okay. So note number 1. So I'm just taking a time of ascent in the presence of air divided by time of descent in the presence of air is equals to how much? U by g plus r by m divided by v by g minus r by m. Okay, so it is in the form of a by b by c by d. So we can write ac ad by bc. So a into g minus r by m divided by v into g plus r by m. So this is the ratio of time of ascent to time of descent in the presence of air resistance force. Okay, are you getting me? Any doubts? Right. So note number 2. So if I want to find the ratio of their velocities, then we can write u by v. I'm just keeping this u by v here only and bring this g plus r by m to this side. It becomes Ta into g plus r by m divided by Td into g minus r by m. And this equation gives what? The ratios of the velocities of the objects in a vertically projecting direction as well as freely falling direction. Any doubts? So pause the video and write the notes. 3, 2, 1, go. Right. So this is the end of the today's lecture, and this is a very small concept. So with this lecture, we have successfully finished the motion in a straight line chapter without skipping even a small concept also. We have discussed all the concepts which are in a motion in a straight line chapter. Okay. I hope that you are enjoyed the chapter and keep watching. This is the end of the today's session, and this is Rakesh signing off. Jai Hind.